Hi there, Year 12 Physics students. Today we're going to have a crack at equilibrium. This is one of the toughest parts of physics this year, so you'll probably need to watch this video more than once. The first thing here is we've got a plank sitting on its fulcrum. One thing about this plank is that it's got a uniform distribution of mass, which means the density of the plank is constant the whole way. If that's true for an object, that means that we can say that its center of mass is bang on in the middle at that point there, which means there's an equal amount of mass on this side trying to make it turn clockwise as there is on this side trying to make it turn anti-clockwise. So it just sits there balanced nicely. If, for example, this side was made from metal and this side was made from wood, even though they'd have the same volume or same lengths, then the heavier side would make it turn that way. But we've not got that kind of scenario here. Alright, which means that we can just put an object here, which is going to be one person, is going to be standing there, and we're going to put another person, and we'll put them over here. So you can see they've got different distances. If this is truly an equilibrium, that means that this person would have the most mass. Alright, so I've labelled the respective distances and this mass here. We'll call this person person A, and this one up here is person B. So we're going to try and find the mass of person A is our job. So I'll put that up. Mass of A is equal to question mark. That's what we're going to try and find. We know they're in equilibrium. Equilibrium means that the torque's going this way, which is from this person A, trying to make it turn that way, is equal to the torque's trying to make it turn that way. So our torques are equal and opposite. Another way you can write that is to say that the sum, so this is Greek symbol sigma, sum of torques is equal to 0. Because these are in opposite directions, if you added them together, you would get 0. So that's another way of writing it. Now what we've got to do here is bring in our torque formula, which is force times distance. So we're going to write force times distance. Okay, that's because torque is equal to force times distance. We can get rid of the torque and we can put in a force times a distance. And we can do the same on the other side, a force times a distance. Now, our next thing is we don't have any forces. We've just got a mass and we're trying to find a mass. So we're going to substitute out force. To do that, we can use the formula force is equal to mass times acceleration. So we can put, instead of force, we can put an m times an a, because an m times an a is equal to a force. So it is m-a-d, mad, it's my favorite formula, is equal to mad. Now, because this is all works, the acceleration here is due to gravity, that means instead of just using general acceleration, we should be able to switch it to g for gravity. And that gets rid of our mads, sadly. Alright, now what we've got to do is start substituting in. So this one here is called mass of A. So mass of A times 9.81 times 5.2. Notice that all distances are measured from the pivot point. So it's from there over to the center of person A. Sometimes they won't give you the measurements from the pivot point and you'll need to use addition or subtraction to find them out. But not in this case. It's a simple one to start with. And on this side we've got mass. This is mass of person B. And we put in their value of 60 times 9.81 times the distance for that person is 4.1. Alright, so our next line of working is mass of person A times 5.1 is equal to 2,413. Now we've got to rearrange it to make the mass of subscript A, person A, is equal to 2413 divided by 5.1. That rearrangement was just done by dividing both sides by 5.1, and on this side we get to cancel out the 5.1s. Whoops, just spotted that it should be 51, not 5.1. And anyway, it gives us an answer of 47.3. And that should round to 47. And that is in kilograms. And that agrees with what I pointed out at the start. Because this person is closer to the pivot point, they will be heavier. So this person was 60 kgs. This one was further away, and they were only 47 kgs is what we've just worked out. Thank you for listening.